this frame, frame A, B, C, D, B, C, D. Okay, I want to change the support at A to pin support. Okay, the CD is loaded with W 30 kilo Newton per meter. This is 6 meter. Okay, this is 5 meter and 5 meter. Okay, I want to set EI is not constant. So for EI, AB is 2 EI, BC is EI, and CD is EI. Okay. Okay, first thing to do before we continue, we have to identify whether this frame is actually side sway frame or not. Okay, looking at this frame, the frame is not symmetry due to geometry and due to loading, because frame without side sway or no side sway frame, it must be either one of these: frame without side sway, or no side sway frame, or non-sway frame. Okay, this will be depending on two conditions. Number one, Number one, it must be symmetry. It must be symmetry. For frame without side sway, we will consider the frame, there is no movement, no side sway. Okay, no movement, no side sway. Whenever the frame is symmetry due to loading and geometry. Due to geometry. Okay, if it is unsymmetry, means the frame is tend to move sideway. Okay. Number two is properly restrained. Properly restrained. Properly restrained means no side movement, no side sway. B and C remain at same position because of restraining force. No, properly restrained means no movement. Symmetry frame in terms of loading, and geometry. Symmetry frame is frame with no movement, no side sway. Unsymmetry frame, but when it is properly restrained means there will be a restraining force that is exist due to support. So the frame cannot move sideway. So it is properly restrained. So if these two conditions occur, the frame cannot move. It is frame without side sway, or no side sway frame, or non-sway frame. No movement. Okay, the movement normally the movement we will determine the movement at B and at C. Side sway Side sway means there will be delta at B and C. Side sway. Symmetry frame has no side sway. Unsymmetry frame, but when it is properly restrained, it is also no movement. It is non-sway frame. Okay, so this frame is unsymmetry. So this is side sway frame. For side sway frame, we have to solve this by applying principle of superposition. It is principle of superposition. Why we need to apply the principle of superposition? Because in this frame, the FEM will be 2. One is FEM due to external loading, and another one is FEM due to delta, due to side sway. FEM due to external loading and FEM due to delta, we cannot combine these two together. We have to calculate it separately. We have to analyze non-sway frame for table number 1, the first part. We have to make this frame as non-sway frame. We have to change this original frame to properly restrained frame, and then we can calculate FEM due to 30 kilonewton per meter, the W only, without delta. Original, it has delta, it has external loading. Okay, and we have to have table number 2. Table number 2 is frame with side sway only. The FEM we calculate based on external loading only. No. The side sway frame, we calculate FEM due to delta only. Table 1, we calculate FEM due to external loading only. Table 2, we calculate FEM due to delta, due to side sway only. Because of FEM. FEM occur due to two conditions. One is external loading. Another one is due to delta. Okay. So this frame is unsymmetry. It is side sway frame, and in this frame there are combination of external loading and delta and side sway. So we have to have two tables. Table number 1, FEM due to external loading only. Table number 2, it is FEM due to side sway only. Due to side sway only. Okay, so from principle of superposition, this is original. Pin here, fix. This is original. Okay, this is equal to, okay, when we want to calculate FEM due to external loading only, we have to change this to become properly restrained frame. Okay, this 30 kilonewton per meter, 30 kilonewton per meter subjected along member CD, and it will push the frame to move to left direction. this frame moving towards left direction. So due to that, we have to put an artificial support at B, pin at B. So due to that artificial pin support, there will be R here. R is positive because the frame, okay, this is A, this is B. The frame, due to loading, it will move to the left direction. Move to left direction. So we have to apply pin at B. So by having the pin support at B, the frame is properly restrained. The frame is properly restrained. So this one is not complete. It's not completed yet until we have another one, another frame, because we have to neutralize the R. We have to neutralize the R. So we have to add another frame. This is pin. This is fixed. Okay, no W. No W. It is just delta. It is just delta. Okay, this delta is occur because we have negative R here. Because we have to neutralize the R that is exists due to the artificial support in diagram B. So in diagram C, it is side sway frame. Side sway frame, and at B there will be delta, at C there will be delta. So FEM in diagram B, this is due to external loading only. Okay, and in diagram C, this is due to side sway only.